If you walk 2 kilometers north, 5 kilometers east, and 6 kilometers south, how far are you from where you started? Okay, let's draw a picture. First things first. We'll label our picture as an X and Y coordinate system. We do not need to go north, east, southwest. North, east, southwest, which we're literally just talking about positive and negative Y and positive and negative X. So we're just going to keep with these dimensions. And let's just draw some vector components here. Each one of these, that's my first vector, V1 vector. Here will be second one, and here's the third one. So V1 vector, what is it? 2 kilometers north. So right there, there it is right there. We'll call that V1 vector. And it is a vector because it has direction. It's not just a number. It is a direction as well. 5 kilometers east. Okay, never eat soggy worms, so it's this way, and it's 5 kilometers. So it's about that far right there. That's going to be V2 vector. And then V3 vector, 6 kilometers south. Oh my goodness, all the way down here. There it is. That's V3 vector. Okay. And then what am I looking for? I'm looking for the magnitude, how far were you started. So I'm looking for the resultant vector right there. We'll call that V final vector, or resultant. And we can write down this equation. Here's my general equation, that V1 vector plus V2 vector plus V3 vector, this plus this equals V final vector. And that's what we want. Well, we want the magnitude of that. But let's start off with this. So what's V1 vector? V1 vector in vector format is going to be, how much did I move in the x direction? 0 in the x hat plus y direction. Oh, yes, it was 2. 2 kilometers y hat. Now, I could put the kilometers here to indicate my units, but I know it is, but that would be the proper way of doing it. V2 vector would be, so this is going to be 5 kilometers plus 5 in the x direction, plus 0 in the y direction, kilometers. And V3 vector is going to be 0 in the x direction minus 6 in the y direction. It was minus 6, or south, but minus 6 in the y direction. Let's add up all those vectors. So plus all these up. So V1 plus V2 plus V3 is going to give me V final. I'll write down V final here. Vector is equal to 0 plus 5 plus 0 is going to be 5 in the x direction. They don't cross mix. You don't add x's to y's. It makes no sense. They're completely independent. They're independent dimensions. So now we put the y direction by itself. 2 plus 0 minus 6 is going to give me minus 4 in the y hat direction. There's your answer. That is the location of the final direction. But I don't really want that. I want to have the magnitude. That's what I'm really asking for here. So the magnitude is equal to the square root of the v final in the x direction squared plus v final in the y direction squared. In that case, it's going to be v final vector is equal to square root of v final x is going to be 5 squared plus, bracket open, this one's negative 4. Now this all goes inside the squared here. Okay, so it really doesn't matter if it's positive or negative. It's just going to be squared because squared is going to make it always positive. And that makes sense for a distance. I don't really care if it's positive or negative. All I'm caring about is how far I am from where I started. So this is going to be 5 squared plus, bracket open, negative 4, bracket closed, squared. If you don't put that bracket there, you're going to have negative 4 squared, then a minus attached to it. So it actually gives you the wrong answer. So you got to put the bracket there, or just not include the negative at all. Square root that answer, you're going to get 6.4 kilometers. And that is our answer. That's how far you are. You always should get a positive value because that's the distance. It has nothing to do with telling me where I am. It just tells me how far I am.